Hello friends, welcome back to the CSC. And this is our second lecture of our second lecture of we discussing second chapter in computer networks. So let us start this lecture by discussing point-to-point protocol. Point-to-point protocol is a data link layer protocol used to establish a direct connection between two nodes, typically over a serial link. It is a widely used protocol for point-to-point connections, such as dial-up modem connections and dedicated leased lines. PPP provides a standard method for encapsulating datagrams over a serial link, allowing multiple protocols to be transmitted over the same link. PPP has several features that make it a popular choice for point-to-point connections. First is multi-protocol support. PPP allows multiple protocols such as IP, IPX and AppleTalk to be transmitted over the same link. Next is error detection and correction. PPP uses a 16-bit or 32-bit cyclic redundancy check to detect errors, and it can also correct errors using error correction protocols. Next is link configuration. PPP allows for dynamic configuration of the link, including setting the maximum transmission unit and the authentication protocol. Next is authentication. PPP supports various authentication protocols such as password authentication protocol and challenge handshake authentication protocol. These were the features. Next, let us discuss sliding window protocol for data link layer. Sliding window protocol is a flow control mechanism used in the data link layer to prevent the sender from overwhelming the receiver with too much data. It is a popular protocol used in many data link layer protocols, including TCP. How does it work? First is window size. The receiver sets a window size which is the maximum amount of data it can receive before sending an acknowledgement. Next is sender's window. The sender maintains a window of outstanding packets, which is the number of packets it can send before receiving an acknowledgement. Next is packet transmission. The sender transmits packets up to the window size and waits for an acknowledgement from the receiver. Next is acknowledgement. The receiver sends an acknowledgement for the packets received correctly, and the sender slides the window forward by the number of packets acknowledged. Next is error detection. If the receiver detects an error, it sends a negative acknowledgement and the sender retransmits the packet from the last acknowledged packet. Now let us see some benefits of sliding window protocol. First is flow control. It prevents the sender from overwhelming the receiver with too much data. Error detection and correction. It detects errors and corrects them by retransmitting packets. Efficient use of bandwidth. It ensures that the bandwidth is used efficiently by transmitting packets in bulk. Next, let us see the working mechanism of token ring topology along with its control frames. Token ring is a local area network LAN topology that uses a ring-shaped configuration to connect devices. It is a popular topology used in many LANs due to its high speed, data transfer rates and reliability. Now let us see how does it work. First is token passing. A special packet called a token is passed around the ring, allowing each device to transmit data when it receives the token. Control frames. There are three types of control frames used in token ring: token frame, data frame and abort frame. The token frame is used to pass the token from one device to another. The data frame is used to transmit data from one device to another. And the abort frame is used to abort the transmission of a data frame. How does it work? When a device receives the token, it can transmit data frames to other devices on the ring. If a device receives a data frame, it checks the destination address and forwards the frame to the next device on the ring. If the destination address matches the device address, it receives the data frame. This is how it works. Next, let us see framing. What is framing? And what are different types of framing protocols? Framing is the process of dividing a stream of data into manageable chunks called frames. It is an essential function of the data link layer as it allows devices to transmit data efficiently and reliably. Framing involves adding control information to the data such as headers and tailors to facilitate error-free transmission. Let us see some framing protocols. There are several types of framing protocols. That includes high level data link control framing. High level data link control framing is a popular framing protocol used in many WANs. It uses a 32-bit CRC for error detection and correction. So see, this is the HDLC frame format. Flag is of 1 byte, address is of 1 byte, control is of 1 byte, information is of variable type, FCS is of 4 bytes, flag is of 1 byte. Point-to-point protocol framing. It is a framing protocol used in point-to-point connections. It uses a 16-bit or 32-bit CRC for error detection and correction. Next, PPP frame format. That is point-to-point protocol frame format. The frame format is like this. The flag is 1 byte, address is 1 byte, control is also 1 byte, protocol is 2 bytes, information is variable type, FCS is 2 or 4 bytes, flag is 1 byte. This is PPP frame format. Next we will see Ethernet framing. Ethernet is a framing protocol used in LANs, local area networks. It uses a 32-bit CRC for error detection and correction. So this is Ethernet frame format. Preamble is of 7 bytes. Destination MAC is of 6 bytes. Source MAC is of 6 bytes. Length is of 2 bytes. Information is variable type and FCS is of 4 bytes. So this was we discussing framing. Next, let us see some design issues of data link layer. The data link layer is responsible for providing error-free transfer of data frames between two devices on the same network. The design issues of the data link layer include error detection and correction. The data link layer must detect and correct errors that occur during transmission. Flow control. The data link layer must prevent the sender from overwhelming the receiver with too much data. Frame synchronization. The data link layer must ensure that the receiver is synchronized with the transmitter to receive frames correctly. Addressing. The data link layer must provide a mechanism for addressing devices on the network. Frame formatting. The data link layer must format frames correctly to ensure error-free transmission. Multiplexing. The data link layer must multiplex multiple devices on the same network to share the bandwidth efficiently. Quality of service. The data link layer must provide quality of service guarantees to ensure that critical applications receive sufficient bandwidth and low latency. Next, let us see some important points. First, let us see three categories of multiple access protocols. They are random access, controlled access, and channelization. Next, let us see what is random access. Random access is a multiple access protocol where devices transmit data at any time and collisions are resolved using techniques such as CSMA or CD or Aloha. Next, let us see three protocols in random access category. What are they? Aloha, then CSMA or CD, and slotted Aloha. Next, let us see controlled access. Controlled access is a multiple access protocol where devices are assigned a specific time slot or frequency band to transmit data and collisions are avoided. Next, what are three protocols in controlled access category? They are token ring, token bus, and FDDI. Next, let us see what is channelization. Channelization is a multiple access protocol where the available bandwidth is divided into multiple channels and each device is assigned a specific channel to transmit data. Next, what are the three protocols in channelization category? They are FDMA, TDMA and CDMA. Next, what is collision issue? Collision is an issue in random access protocols because multiple devices can transmit data at the same time, resulting in data corruption or loss. Whereas in controlled access and channelizing protocols, devices are assigned specific time slots or channels, avoiding collisions. Next, let us contrast random access versus controlled access. Random access protocols are more suitable for bursty traffic and it have lower latency, while controlled access protocols are more suitable for continuous traffic and have higher throughput. Next, let us contrast random access and channelizing. Random access protocols are more flexible and adaptable, while channelizing protocols are more efficient in terms of bandwidth utilization. Next, let us contrast controlled access with channelizing. Controlled access protocols are more suitable for LANs, local area networks, while channelizing protocols are more suitable for wide area networks. Next, what is multiple access protocol in local loop? Uh, do we need a multiple access protocol when we use the local loop of the telephone company to access the internet? Why? No, we don't need a multiple access protocol when using the local loop of the telephone company to access the internet because the local loop is a point to point connection and multiple access protocols are used in shared media networks. Thank you.